Hello students, welcome to Math Online Academy by Sandhya. Myself Sandhya. Today topic is irrational numbers. Already we discussed rational numbers and their concept and their conditions. If they are rational numbers means what is the condition of p value, q value, like that. In this we discussed what are irrational numbers. The number which cannot be written in the form of p by q is called irrational numbers. Rational numbers means you write it in the form of p by q. Irrational numbers means the numbers which cannot be written in the form of p by q. So you can't write in the form of p by q. Those are all called irrational numbers. And those are represented by q dash or s. Those are not in the form of p by q. Okay. And according to decimal form, rational number has the decimal form. According to decimal form, non-terminating, non-recurring and non-recurring decimal numbers. Non-recurring decimal number. For example, let's see, root 2 and root 3, root 2, root 3, root 5 and pi, e value. These are all called non-recurring, non-terminating decimal forms. Okay. These are irrational numbers. For example, in the question, in board exam, write the definition of irrational numbers and give two examples. If asked, you write the number which cannot be written in the form of p by q is called irrational numbers. Examples are, you can write any example. For example, 1.2, 1, 3, 4, 5. This is also one irrational numbers. And 0.1, 2, 3, 1, 5, like this. Those are not repeating. So, you can write any in the form of decimal form. That is irrational number. Okay. You can write roughly these numbers are also irrational numbers. Okay. This is the definition and these are examples. These are root 2, root 3 and in this one condition is there. If for example p is prime number, then root p is irrational. Yes, is it correct? Root 2 is prime now. So root 2 is irrational. Root 3 is irrational. For example, root 4. 4 is not a prime number. So for root, you write 2 into 2. Factorize. So root 2 square. Root 2 square means it will come 2. So this is not a irrational number. This is rational number. These are irrational numbers. If p is prime number, then root p is irrational number. Okay. Next, we discuss one important theorem. That is theorem number 1.2 in page number 6. Okay. Next theorem 1.2. Let p be a prime number if p divides a square, then p divides a. where a is a positive integer. Based on this theorem, we solve next questions and next theorems also. Those are very important. This is, we use only concept purpose. This concept is important, not theorem. Using this concept, we solve next. For example, they give the root 2, root 3, root 5. Those are rational numbers or irrational numbers. Show that root 2 is irrational number. This is the most important question for board exams. So here what? Prime number p divides a square. For example, let's see. 5 divides 25. For example, 5 divides 25 means 25 5. This is the process now. So 5 divides 25 means 25 is divisible by 5. Is it clear? So here p divides a square means a square is divisible by p. 5 divides 25 means 25 is divisible by 5. Okay, is it clear? So 5 divides, you can write 5 square na? 5 square. And so 5 divides 5 square means, see 5 divides 5 na? In 5 divisible by 5. This 5 divisible by 5 na? So then p divides a, where a is a positive integer. A is a positive integer. 5 is a positive integer, and here p means here 5. Again 5. 5 is prime number. So 5 divides 5. Based on example, 5 divides 25 means 25 is divisible by 5. So 5 divides 5 square. Here 5 divisible by 5. So 5 divides 5. One more example. 5 is compulsory prime number. Here p is compulsory prime number na. So that implies p divides, based on this example, p divides a. A is positive integer. A is a positive integer. Okay? Okay? One more example. See? For example, let's say in place of p, take 2. 2 is a prime number. So 2 divides 16. We want here square. So here I took the 16. And again 2 divides 4 square. You can write 16 equal to 4 square. So here 4. 4 is divisible by 2. 2 divides 4. So based on these two examples, p divides a square. If p is prime, p divides a. A is a positive integer. Okay, this is the theorem. Based on this theorem, we solve some examples. Show that root 2 is the irrational number, root 3 is the irrational number, root 5 is the irrational number. So this concept is very important, but using this concept we prove the examples. Those examples are, see, root 2 and root 5, root 3. These three are very, very important. I will explain. Root 2 is, show that root 2 is a irrational number. What is the question? Question number is, see, theorem 1.3, root 2 is irrational. See, root 2, theorem what? 1.3. Theorem 1.3, root 2 is irrational. Irrational means that is not in the form of P by Q. Yes, is it right? That is not in the form of P by Q. Okay. For proving root 2 is irrational, we can't prove directly root 2 is irrational. Indirectly, for solving this, let us assume controversy. Controversy means opposite. If you here root 2 is irrational, we have to prove root 2 is irrational. So controversy means you take root 2 is rational numbers. If you prove root 2 is rational numbers, finally it comes true or false, whatever. If for example, finally it comes false. False means root 2, we are proving root 2 is rational numbers. That came, final answer is false means indirectly that is irrational numbers. For example, I will, a person wants to go destination B in this way. He asked to one person, please tell me, I want to go destination B. So he said, one person said, you go this way, you can reach the destination B. But wrongly he started to walk this direction, in another direction. Finally he reached here. This is the dead end. This is dead end. This is dead end means again he has to start it from here to here. Na? This is the wrong means this is the correct. Na? First, this a person thought to go, this is the not way, this is the right way. He started from A point to this end point. He started this way. He didn't reach the destination B. So, what this way is wrong. So, I have to start again from A to this direction. That is the correct, this is the wrong. First we choose this is the right direction. After reaching, he realized that is not right, that is wrong. That is wrong means another direction is right. Okay, here also same. For example, root 2 is irrational numbers. Proving root 2 is irrational number is little bit difficult. In that way, let us root 2 let us assume root 2 is rational. Root 2, we are assuming root 2 is rational. At the end of the problem, we get the root is not a rational number. Means root is not a rational numbers means that is irrational numbers. Let's see. By proving, you get the little bit clarity. Let's start. Root 2 is rational numbers. Root 2 is rational numbers means what is the form of rational number? P by Q. So, root 2 equal to A by B. That is in the form of A by B. Na? Rational numbers means that is in the form of A by B. A by B means A comma B are co-primes. Yes. If you write the factorization, these two are co-primes and positive integers. Yes. A comma B belongs to integers, and here b not equal to 0. Yes. Next, a equal to root 2 b, and that implies squaring both sides. If you do squaring both sides, a square equal to root 2 b whole square means a square equal to 2b square. A square equal to 2b square means 2 divides a square. This is even number, na? Yes? Means 2 divides a square. 2 divides a square. We discussed before theorem. P divides a square means P divides a. So 2 divides, for example, a equal to 2c. A equal to 2c. A equal to 2c means 2c whole square 2b square. So here 4c square equal to 2b square. 2b square means b square equal to 2c square. Yes. Observe this equation and this equation. Means 2 divides b. 2 divides, this is second. So 2 divides b square. Based on above theorem, theorem 1 above theorem, we discussed p divides a square means p divides a. Same. 2 divides b. So here what is the 2 divides a, 2 divides b. So 2 is the common factor of a comma b. 2 is common. 2 is common factor of a comma b. What is the condition for rational numbers? Those two are co-primes. So common factor is only 1. Here 2 is common factor. Means the a comma b are not co-primes. A comma b are not co-primes. Not co-prime means root 2 is not a rational number. Not a rational number means irrational number. Root 2 is not a rational number. Not a rational number means if we are proved this is false means that is true. So root 2 is irrational number. So once again let's let us assume. In this question first we have to show root 2 is the irrational number. Directly showing irrational number is little bit difficult. That's why we are taking controversy. Controversy means opposite. So let us assume root 2 is rational. Rational means what are the conditions for root 2 the rational numbers? Those are in the form of p by q. Here we are taking a by b. A by B, and those two are co-primes. If you factorize, na, those become co-primes. So A comma B are co-primes, and A comma B are positive integers, and B not equal to 0. So A equal to root 2B. Squaring both sides, you get this one. Means A square equal to 2B square means this is 2 is even number. So 2 divides the A square. 2 divides A square. 2 divides A square means before the theorem we know prime divides A square means that prime divides normal number A. So 2 divides A. Let, for example, A equal to 2C. For proving B value. A equal to 2C. So 2C square equal to 2B square. And again 4C square equal to 2B square. 2 2s and became B square equal to 2C square. 2 divides B square means from the above theorem 2 divides B. 2 is a common factor of A comma B. Here already we mentioned A comma B are co-primes. Co-prime means that common factor is 1. But here 2 is a common factor. It is not possible. So A comma B are not co-primes. Not co-prime means root is not a rational number. Not a rational number means root is a irrational numbers. Same method you can solve next question root 3 in place of root 2, root 3 and root 5. Same na? 2, 3, 5. These are rational, primes. Say you use here 2, 3 and 3, 5. Using the same method, you can solve root